Hello everyone. I'm going to now go over the review questions for test 2 one by one and explain the solutions. The first question is on discrete random variables. So let's read through the question first. It says the following is the data on the number of siblings of randomly selected students in a statistics class. The table displays a frequency distribution for the number of siblings as reported by 40 students. Let X denote the number of siblings of a randomly selected student. So the data is given to us in the form of a horizontal table. We first have the number of siblings, which represents our variable. And these are all discrete values. That's why these are discrete random variables. Correct? Discrete means countable values. Number of siblings, if somebody asks how many siblings you have, you're going to give a countable value. You have to count up the number of siblings you have or somebody else has and list them. So the number of siblings listed here are 0, 1, 2, 3, 4, 5, and 6. And these are the frequency values. That means 8 people responded. They had 0 siblings, meaning they were single child. They did not have any siblings. 17 said they had 1 sibling. 11 people responded. They had 2 siblings. 3 people responded. They have 3 siblings, 1, 4 siblings, and 5 and 6, 0 people responded. They had siblings, 5 or 6. So the total number of respondents is the sum of the frequency, which also represents n, or the sample size. So n is always the sum of the frequencies. Please, for n, do not add up these values of the variable 0, 1, 2, 3, 4, 5, 6. No, these are not, they don't represent n in any way. N is the sum of frequencies, so 8 plus 17 plus 11 plus 3 plus 1 should give you a value of 40. So N should be 40, all right? So sum these values up for the frequencies, and N should be equal to 40. And that should match with what is given in the question. It says a frequency distribution for the number of siblings as reported by 40 students. So that represents your n. Now, the first part of the question says find the probability represented as P of X, the capital X being the variable we are studying, which is number of siblings, equal to a specific value of X. So it says we have to find the probabilities, the different probabilities for this entire table. You may use the table below to find the probabilities. So P of X equals small x, right? So what is the formula to find probability? It's the same old formula, which is F over N. P, the probability formula, is F over N. So it's going to be 8 divided by 40. 8 divided by 40. Again, you have to convert it to a decimal value. Many of you left your answers as fractions in the first test on the probability questions. I have given you the points there, but for this test, I'm going to deduct points if you leave your probability answer as fractions. It has to be converted to decimals, all right? That's how we represent probability values. So please do not write this as, don't leave it as 8 over 40. Convert it to fractions, which should be 0.20, and then 17 over 40, which is 0.425. So you're going to go about working through these entire list of frequency values to come up with the probabilities. Now I've done all the calculations in the table, which I've provided to find the mean of the above. All right, so part B says find the mean of the above using table below. The formula for the mean is sigma x times the probability of x. So in order to find the mean, mu, you have to know the probability of each individual small x values. So what are the small x values? The number of siblings. So this is an x, this is an x. So x is equal to 0 is a value of x, x equals 1 is a value of x. All right, so even though number of siblings, the variable is represented by the capital, the uppercase letter x, the individual values of the variables are represented by the lowercase x. So let's go through this table, which I will provide you for the test, but you have to fill it up. All right, you have to know what steps to go about to find the mean. So in the first column, I've listed all the x values. So 0, 1, 2, 3, 4, 5, 6. These were the number of siblings reported by the students. That's your lowercase x. In the next column, I have listed all the frequency values. So essentially, in the first two columns, I've listed the values already given to us. You just copy them and list them in this table in the first two columns. In the third column, we have to find the probability of x. So it's 8 over 40, 0.20, 17 over 40, 0.425, 11 over 40, 0.275, 3 over 40, 0.075. So the way you calculate your probability values, take your f values and divide by n. F over n is the formula to find any probability, right? So make sure you calculate your probabilities using this formula. Now, for the formula of the mean, it's a sigma x times probability of x. That means first we have to multiply all the probability values we found in the third column by the x values in the first column. So that's what I've done in the fourth column. So 0.20 times 0. All right, so 0.20 times 0. Let me see if I can just draw a line. So all right, you're multiplying 1 times 0.425, you're multiplying the values. 2 times 0.275. So in the fourth column, it's x multiplied by the probability. So 0.2 times 0 is 0. Again, all your decimals should be up to the third decimal place. Again, I saw a few of you rounding up to 2 decimal places. Please don't do that. Please round it up to 3 decimal places. Do not round it up to 2 decimal places unless the question specifically asks you to. All right, so we have x times probability of x equals x, and these are the values obtained by multiplying the third column with the first column values. All right, so 0.075 multiplied by 3 is 0.225. 0.025 multiplied by 4 is 0.100. And at the end, you sum it up. So when we sum it up, it's sigma x times probability of x equals x, and that is the value of the mean. That is mean. All right, so just write it up here. So again, just to go over it one more time, list all your x values which will be given to you in the first column. In the second column, list all your f values, and then in the third column, find the probability values for each different x value by doing f over n. And then in the fourth column, multiply each probability value by the corresponding x values, sum them up, and you got your mean, the value of the mean. All right, so Again, the formula will be provided in the formula sheet. It's sigma x times probability of x equals 1.310. How did we get this? From this table, by summing up the values in the fourth column. All right, so that's the way to find the mean. To find the standard deviation, which is the third part of this question, it says obtain the standard deviation sigma of the random variable. Use the table above and show calculations below. Now I've used the computing formula. If you want, you can use the defining formula. However, the computing formula is way faster. All right, so you may just want to use the computing formula. It's square root over x squared multiplied by the probability of x equals x minus mean squared, mu squared. So we already found mean in the previous part, which is 1.310. All we have to do is square it up, but we need to find x squared probability of x equals x. Now let me correct something here. It should be sigma. All right, this should be sigma x squared probability of x equals x, not just x squared. All right, it should be sigma. So in this last two columns, I've done that calculation. In this column, which is the fifth column, I've squared all my x values, because the formula says sigma x squared times probability of x equals x. So x squared 0, when x is 0, x squared is 0. When x is 1, x squared is 1, right? 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. So we found all our x squared values. You don't need to sum those up. However, you have to first multiply all your probability values, that's the third column values, by the x squared values. So in the last column, I've multiplied x squared times probability of x, the third column, not this column here, which we used to find the mean. Please do not use this column. It's this column multiplied by this column here. So 0 times 0.2 is 0. 0.425 times 1 is 0.425. Again, I cannot repeat this enough times, but please keep your decimals to third decimal place. Decimal values to the third place. 0.275 times 4 is 1.110. 0.075 times 9 is 0.675. 0.025 times 16 is 0.4, and so on. All right, and the last two values are 0 because the probability values for 5 and 6 were 0. Okay, so once we have all these values, just sum them up again. So you got the first term, all right, x squared times probability of x equals x summed up is 2.610. All right, so now go to your question here, to the formula, and plug in the values. Sigma x squared times probability of x equals x is 2.610, and that's what I have here, 2.610 obtained by summing up the last column. And then minus mu squared, so 1.310, which is the mean, squared, and then we have to take the square root of all that. So 2.610 minus 1.716 is 0.894. The square root of that is 0.9455, and that's the answer for the standard deviation. All right, so that completes the first question in your test 2 review package. All right, so then in the next question we are going to work on a problem to find binomial probability. So here's the question on binomial probabilities. The previous question was on discrete random variables. So discrete probabilities, this was on binomial probabilities. And if you recall, binomial probabilities have just two outcomes, right? So a success outcome or a failure outcome. A success outcome happens when you find the condition or the attribute you're looking for, and the failure occurs when you do not find the condition or the attribute you're looking for. All right, so let's read this question here. It says the probability is 0.40 that a traffic fatality will involve an intoxicated or alcohol impaired driver or non-occupant. In 8 traffic fatalities, find the probability that the number y that involve an intoxicated or alcohol impaired driver or non-occupant is exactly 3, at most 3. So these are the different probabilities that we have to find, right? So I'm going to go through this question one more time and extract some values. Now, binomial probability goes with this formula here, all right? It's n combination x, represented with this notation, times the probability raised to the power x times 1 minus p raised to the power n minus x. Now, p is the probability value. So we need to find what p is. We need to know what 1 minus p is. Now, if we know p, then we can calculate 1 minus p. All right, that's a no-brainer. But 1 minus p represents the failure probability and p represents the success probability. So if what you have been looking for is found, then that is your success probability. What are we looking for here? It says find the probability that the number y that involve an intoxicated or alcohol impaired driver. So we are looking for looking to find an intoxicated driver that caused a fatal accident, all right, or that may or may not have caused a fatal accident. All right, so p over here, the probability is given as 0.4. So p is 4.4, what I write here. 1 minus p, therefore, or the failure probability is 0.6. What is n? N is the number of traffic fatalities that we are looking at. All right, that one by one we are looking at. All right, first fatality, second fatality, third fatality. So if you drew your tree, all right, let me get my pen out here. So if we were doing a tree, so if in the first draw, so you are basically drawing 8 times, right? That's what this 8 traffic fatalities mean. All right, so draw the first time and see whether there was a fatality or not. Pick a second accident and see if you're getting an intoxicated driver in the second draw or not. Then third, fourth, all the way to 8. All right, 8 times you are drawing to see whether you get an intoxicated driver from the different fatal accidents in 8 traffic fatalities. Now, one thing I want to mention is sometimes the data is kind of camouflaged. You're looking for a number, but the data can be camouflaged in words, written out in words, as in this case. All right, so please read your questions carefully to locate your values. So over here, n is 8. All right, so we got our n, we got our p. Now we just need to know our x. Where do we get the x value from? X value comes from the different parts of the question. For example, in part A, it says, what is the probability that the number the number of fatalities that involve an intoxicated driver would be exactly 3. All right, that you would get 3 intoxicated drivers caused the fatal accidents. Okay, so that will represent your X. The first question says express in notation form. What we are looking for is the probability that X, or the variable here is the intoxicated driver or alcohol impaired driver, right? That represents your variable, and the number of intoxicated drivers that gets selected is 3 in this question. All right, so that's how you write it in notation form. Now we go ahead and find the probability. Again, the formula is n combination x, so you just plug in your values. N is 8, so I have 8 here. X is 3. 0.4 represents your P, and X represents 3, this value here. Now, 1 minus P is 0.6, and N minus X, N is 8, so 8 minus X is 3, 8 minus 3 is 5. All right, the way to cross-check is that you got both your exponents correct, is just add 5 and 3, the exponents, and make sure you get back your value of N. 5 plus 3 is 8, correct? So we got our values, the exponents correct. So 0.4 cube, 0.6 to the 5th, you have to use your calculators. 8 combination 3 is what we need to calculate. This combination formula itself has a formula of its own, right? So I've shown you how to use the factorial formula, use factorials to do this calculation. 8 combination 3 can be evaluated using the formula n factorial, all right, here n factorial divided by x factorial times n minus x factorial. So 8 factorial divided by 3 factorial, which is the x. So this is our n, this is our x. So just plug in the values. 8 factorial, how do you calculate factorial? 8 times 7 times 6 times 5, 4, 3, 2, 1. Multiply them out. And over here in the denominator, it's 3 times 2 times 1. And then 5 times 4 times 3 times 2 times 1. Instead of multiplying everything out, it's better to simplify it while they're still in factors, right? And I get 56 for my 8 combination 3 after I simplify the factorials. And then 0.4 cube is 0.064, 0.6 to the 5th is 0.0778. Multiply them out and we get a probability value of 0.278, right? So probability of x equals 3 is equal to 0.278. So that's how you are going to calculate binomial probabilities. Again, the formula will be given to you in the formula sheet. You just have to plug in the values correctly and do the calculations. All right. So this was part A. For part B, it says at most 3. All right. So at most 3 means it's not just equal to 3, but 3 is the highest value. It could be values less than 3 as well. So what? So it's in notation form, that's probability of x less or equal to 3. So what are the values that could be less or equal to 3? It could be a 0, it could be a 1, it could be a 2, and because it has less or equal to, we should include 3 as well. All right, so over here, I've written it out. It means the calculations, the way we are going to find this is find the probability of x equal to 0 plus the probability of x equals 1 plus the probability of x equals 2 plus the probability of x equals 3. All right. So probability of x equals 3 we already found in the previous question. So just use that. All right. Just use that value 0.278. You do not have to recalculate. But we do have to calculate probability of x equals 0, probability of x equals 1, and probability of x equals 2. All right. So 8 combination 0. Then 0.4 raised to the power 0. Keep in mind, anything raised to the power 0 is a 1 always, all right? And then 0.6 raised to the power 8. So 8 combination 0 is going to be a 1, but you can do your calculation the way we did it in the previous problem using the formula n factorial divided by x factorial times n minus x factorial. So 1 times 0.6 raised to the power 8 is 0.0168. Then for 8 combination 1 is 8, and then you do 0.4 raised to the power 1, which is p raised to the power x, right? P raised to the power x, and 0.6 raised to the power 7. So when you do the calculation, you get a value of 0.0896. 8 combination 2 is 28, and 0.4 squared, 0.16. 0.6 to the power 6 is 0.046. And these are the different values, probability values we have. We have to sum them up, and we will get a probability of x less or equal to 3 as 0.5934, right? 0.5934. Now, I have already worked and posted video solutions of this kind of problem on the worksheets. So you may just want to go over those. I may have worked some in the lectures also on this topic. So you may want to go over that. Now, for C, at least 3, that means probability of x greater or equal to 3. At least means 3 is the lowest value, and everything higher than that. So that would include 3, 4, 5, 6, 7, 8. That's a lot of probabilities you have to calculate and then sum them up. So what I've done here is I've used the complementation rule. So this is where the complementation rule comes in handy. It really reduces your workload, the calculations. All right. So all I did was 1 minus the probability of x less than 3. So that's, we've already calculated probability of x equals 0, probability of x equals 1, probability of x equals 2, less than 3 stops at 2, right? So 1 minus, I just brought my probability of x equals 0 is 0.0168. For 1, this is for the probability of 1, probability of 0, probability of 2. I sum them up and subtracted from 1. This is so much faster, so much faster than finding the probability of 4, probability of 5, probability of 6, probability of 7, probability of 8. So please go ahead and use the different rules that you learned on probability to make your life easy. There was a reason we went through all those rules, especially the complementation rules. The complementation rule is really very fast and saves a lot of work. So when we did this calculation, we got a probability value of 0.6846. So probability of at least 3, which is represented by the notation probability of x greater or equal to 3 is 0.6846 is what we found here. All right. Now part D is asking, is the probability left skewed, right skewed, or symmetric? It's a very simple rule. If the probability is less than 0.5, it's right skewed. You have to give this explanation. How do you know? If you do not give this explanation, then you are not going to get the full points for this answer. All right? It might as well be a guesswork. We are testing your knowledge, your understanding of this concept. If probability is less than 0.5, it's right skewed. If probability is greater than 0.5, it's left skewed. If the probability is equal to 0.5 or close, very close to 0.5, again, nothing will be exactly equal in statistics, then it'll be symmetric. So the probability that we used or were given is 0.4, which is less than 0.5, and therefore the conclusion is it's right skewed. The next part of the question says find the mean of the above. Very easy formula for the mean of binomial probabilities. I would expect everyone to get it right. Again, mu is n times p. Just take your n, again, make sure you find your n correctly, multiply by the probability value which is given to you. So 8 times 0.4 is 3.2. That's your mean. All right, should be very fast and quick. And then find the standard deviation of the above. So this is the formula for the standard deviation. Sigma equals square root over n times p, which is the mean, times 1 minus p, right? N times p is the mean. And then you have to find the square root by multiplying n times p with 1 minus p. 1 minus p is it's the failure probability, right? So 3.2 times 0.6 was 1 minus p, 1 minus 0.4. So when we do that calculation, we get a sigma value 1.385. So that completes the question on binomial probability. And you will get a similar question on the test. All right. So make sure you know how to solve this problem. It's mainly the calculation of the probabilities, this part which is more intense than finding the mean. The mean is a very easy formula as well as the standard deviation, right? Now the next question is about finding areas under the curve. The question says here, find the area to the left of z of 0.15 and the corresponding z-score value. Show with a diagram. Now, I've shown separately how to use the table to find the areas. Again, the table only gives areas to the left. Now, for this particular problem, the notation, you have to look at the notation given to us. It has z and then a subscript of 0.15, which is the same as the z of alpha notation. When this happens, you should always you should always remember that this notation, z of alpha, means area to the right. All right, it's this subscripted value of 0.15 is indicating area to the right of a particular z value. And this is whenever we write the z in this particular notation, the z of alpha notation. It's an accepted understanding that the subscript will represent area to the right. However, in the question, they're asking what is the area to the left. So before we go to the table to find the area, we have to find the area to the left of 0.15. So the area to the left of z of 0.15 is 1 minus 0.15. correct? So let me just draw a quick diagram here. All right, here's our curve, and based on this notation, it's saying there is this let's say a z curve. So there is a particular z value. We don't know what it is, but the area to its right is 0.15. And the question is asking what is the area to the left. All right, so we know the total area under the curve is 1, so the area to the left will be 1 minus 0.15, which is 0.85. The next part of the question says, what is the corresponding z-score value? So for that, we have to go to the table and find the corresponding z value. You have to look up the area of 0.85 in the body of the table, and the corresponding z value you will find is 1.04, and that is the answer. Again, I have put together a video explaining how to find areas under the curve from the table. Please look up that video. All right, so z of 0.15 is 1.04, and that's the z value. So area to the left is 0.85, and the corresponding z value is 1.04. Okay, I pulled up this table that you must refer to anyway, and I might as well just show you how I came up with a value 1.04 for the z value whose area to the left is 0.85. Again, this diagram up here on the table should tell you that this table only provides area to the left. So we came up with the left area as 0.85. You have to search in the body of the table for 0.85. So 0.85, the closest value is 0.8508, right? So this is the 0.8508. So the corresponding z value is 1.0 to the first decimal place, and then the second decimal place is 0.04. So that's why the z value 1.0 and 0.04, right? 1.0 plus 0.04 is 1.04, right? So that's how you're going to use the table to find the z value whose area to the left is 0.85. Again, when you come to this table to find the z value, you must have the area to the left of that z value. If you were looking for 0.15, let's say you forgot to find the area to the left and looked for 0.15 for the area to the right, you would get a completely wrong z value and your answer would be wrong, right? Now the next problem is an application-based problem to find areas under the curve. So we'll be finding areas between two z values to the left or to the right of a particular z value, as the case may be. But here we will first have to find the z value. All right, so let's read the question. It says here, an average light bulb manufactured by the Bright Lights Corporation is normally distributed and lasts 300 days with a standard deviation of 50 days. So it says here, based on this question, the mu or the mean is 300, right? So it says it is normally distributed. These are some of the key words we need to go ahead and answer this question. Normally distributed and lasts 300 days. How we know this is the mean? It says an average light bulb. So the mean duration that the that the light bulb will last is 300 days, and the standard deviation is 50 days. All right, so between what number of days will the middle 99.7% of all observations lie? Now, middle 99.7%, remember the empirical rule, 68% plus minus 1 standard deviation, right? So let me write that here. Plus minus 1 standard deviation is 68%. Plus minus 2 standard deviation is 95%. And plus minus 3 standard deviation is 99.7%. So you have to memorize that rule and know from there that 99.7% refers to plus minus 3, z value of plus minus 3. So the z of minus 3 and z of plus 3. Now, we then go on to find the x1 and x2 values. All right, so for this particular problem, they're not asking for the area, they are asking for the x values, which will be which correspond to a z value of -3 and a +3, right? So what they're asking here is, let's quickly draw another diagram. All right, this is a normal curve. So there'll be -3 here and +3 here. We have determined that from the 99.7% given to us. And the question is, what are the corresponding x values? So when we talk in terms of z values, the middle value is a 0 z score, but they want to know what the corresponding x values are. So the mean lies at the center, so they want to know how many days would be -3 standard deviations away from 300 and +3 standard deviations away from the mean 300. And this is the formula: x sub 1 equals 300 plus -3 times 50. So that formula to find the x value is derived from the formula for the z score, which is x minus mu divided by sigma. So if you solve for x, you get a formula of x equals mu plus z times, this is z times sigma. All right, so just plug in, all right, the values. Mu is 300, z is -3 in the first case, times 50, which is the standard deviation, and we get a value of 150 for one end. Right, let me use a different color maybe. So this is 150, and when we plug in 3 for z, we get a value of 450. All right, so the way you answer this question is the middle 99.7% of all observations lie between 150 to 450 days. Again, you have to show all your work, all right, all the steps. Otherwise, you won't get the points for the question, all right? Don't just write the answer. That is a very, very small percentage of points for the entire problem, all right? Show all your work, how you determine that z is plus minus 3 from the empirical rule, and then how you apply the formula to find x, the calculation. And if you want, you can draw a diagram as well to make it more clear, and then write your answer as a sentence. The next question says, what is the probability that a randomly selected bulb lasts less than 380 days? Probability is the same as area under the curve. All right, so we use that interchangeably. Area represents not just relative frequency, proportion, but also probability, because probability and proportion, relative frequencies, they have the same formula, F over N. All right, so if we can find area under the curve, then we will know the probability. So the question says less than. What is the probability that a bulb will last less than 380 days? So draw a picture here. All right. So if 300 is the mean and is at the center, then 380 lies somewhere to the right. Okay. So we are interested in the region to the left of wherever 380 is. All right, because it says less than, that means it's the region to the left. So we are looking for probability of x less than 380, mu being 300, sigma being 50, and x is 380. So we first have to find our z value using the formula x minus mu divided by sigma. Do the calculations, and we come up with a z value of 1.6. So that's the z value. We then go to our table to find area to the left, because that is our region of interest. So if I pull up the if I pull up our table, it's 1.6. So 1.6. So you go down your z value. All right, you go down your z column all the way to where 1.6 is and pick up the area. So this time the z value is given, you are finding the area. So start with the z column, locate where 1.6 is, and find the corresponding area, which is 0.9452, and you got your answer. So you will then convert 0.945. Well, you don't need to convert, because probability, they asked for the probability, they didn't ask for the chance, likelihood, or percentage. So 0.9452 should be your answer. Like going back to our worksheet, it says area to left of z of 1.6 is 0.9542. So write it as a sentence. The probability that a randomly selected bulb lasts less than 380 days is 0.9542. That completes this question. Then it says, what is the probability that a randomly selected bulb lasts longer than 287 days? So this time longer means greater. All right, so we are looking for the probability where x is greater than 287 days. So greater means area to the right. This time it's area to the right. So draw your picture, your diagram. Your mean will be at the center, which is 300. And 287 is less than 300, so it will be located somewhere to the left of the center point. Calculate your z value using the formula for z, and we get a z value of minus 0.26. So 287 minus 300 divided by 50 gives us negative 13 over 50, which is negative 0.26. We are interested in the area to the right, but however, you first have to find the area to the left of 0.26 and then subtract it from 1 to find area to the right. Okay, so from the table, we found the area to the left of 0.26 is 0.6026. So to find the area to the right, it's 1 minus 0.6026 is 0.3974. So the probability that a randomly selected bulb lasts longer than 287 days is 0.3974. And finally, they want us to find area to the area between two values. So here the x values are 318 and 432, x sub 1 and x sub 2. So we have to find two z values, one when the x value is 432, and then secondly, when the x value is 318, what is the corresponding z value? Again, we use the formula here to find the z value. Make sure you plug in the values correctly. 432, it's x minus 300, x minus mu. All right, so 432 minus 300 divided by the standard deviation, which is 50. All right, so the z values are 2.64 for 432 and 0.36 for 318. Find the corresponding areas. All right, these are the areas we found, and subtract them. All right, because we are finding areas between two z values. You have to subtract the areas and you will get your probability value. All right, so the probability that a randomly selected bulb lasts 318 to 432 days is 0.3553. Okay. Now, finally, it says what length of days represent the bottom 12% of bulb life. So bottom 12% refers to the area to the left. Because it's bottom, it refers to area to the left. So, all right, so that means area to the left is 0.12. Area to the right is 0.84. And so we have to find the corresponding length of days. That means the x value. So first we find the z value, z of 0.88. All right, so this should be 0.88. All right, z sub 0.88. That means the z value whose area to the right is 0.88. You have to look this up from the table. All right, so it's roughly negative 1.175 approximately. This is not this x value corresponds to the length of days, right? So we find the z value first. We are given the area, we find the corresponding z value, which is negative 1.175. And then we use the formula to find x is mu plus z of sigma, z times sigma. Plug in the values correctly and we get an x value of 241.25. So the length of days representing the bottom 12% of bulb life is 241.25. Okay, so that completes this particular question. Now here we used the formula to find the z value as x minus mu divided by sigma. All right, because we were not working with sample means. We are here in this case, we are working with actual observations of one particular sample. When we work with sample means, then we will use a slightly different formula for the z value, which we will see in the next few exercises. All right, but for this particular question, we are just working with not even a sample, with the population really. Remember, we were using the population mean, mu equals 300. We are not working with samples in this case. And when that happens, your formula that you will be using to find the z value is x minus mu over sigma. All right, we used we worked with a population in this case.